Hey guys, welcome to CyberPlatter. This is a series on cloud security interview question and answers. This video will mainly concentrate on scenario based questions. This is part one. There'll be other parts which I will link them in the description box. Let's go to the first question. Your organization has decided to migrate the entire application infrastructure into the cloud. You are a cloud security architect and you have to make sure that the migration is done well and also adhere to best practices for security and compliance. How do you explain the different cloud service models to your CTO and also the shared responsibility model? So you need to talk about the different types of cloud service models and what is the shared responsibility model for each of these cloud service models, and how is the division of security responsibilities between your organization and the cloud service provider. Now, let's talk about the cloud service models. This is based on the services offered by the cloud service provider. There are three types of service models. First one is infrastructure as a service, platform as a service, and software as a service. To understand this, let's see how, if we want to set up a server, how it will be in cloud. First, let's say there is a server. Okay, this has the memory, motherboard, CPU, right? And then for the connectivity, to connect everything, we need the routers, switches, internet. This is the connectivity part. And then we have storage, which is HDD, SSD, right? And then this is the hardware part. And then we have something called as virtualization software. This is to run like multiple VMs on the same server so that we don't waste space, memory, CPU, right? And then we have the operating system, that is Windows, Linux, and then we have the middleware, and then there is runtime. Runtime can be, if it is web application, it can be IIS. If it is container, it can be Docker. And then we have the application itself, and then there is our data. So it looks like a lot of layers, right? But this can be grouped into three major sections. The hardware and the virtualization software part is called the infrastructure. And then we have runtime, middleware, and OS. This is the software which is required to run the application. It is not the application itself, okay? This is the platform part. And then we have the application and the data, which is our software. Suppose, say, if somebody is taking care of the entire thing from the hardware, so infrastructure is hardware and the virtualization software, right? Including this, and then we have the OS, runtime, middleware, and data application. If everything you're taking care of, then it is the on-prem structure, that you're taking care of everything, you're not taking help from cloud service provider. If the hardware and the virtualization software is provided by the cloud provider, okay, and then the consumer is installing the OS, middleware, application, and the data, then it is called as infrastructure as a service. This is the basic model that is provided by any cloud service provider, okay, and it is least expensive also. Mainly the use cases for infrastructure as a service is for BCDR. It can be used as a warm site where the physical space is provided by the provider and the connectivity as well, and virtualization software and everything that is required to install the application, that is OS, runtime, middleware, and application. Everything is done by the consumer. It can be also used mainly for storage, archiving, backups. Infrastructure as a service is a service where the consumer has the most control over the security of their data. Okay. So when I say least expensive, right, it is least expensive in terms of what you're paying to the provider. But consumer will have to take into consideration that, we might need extra staffing, IT staffing to make this entire thing work, because OS responsibility, middleware, runtime, application, data, everything falls to the consumer. So the physical part of the infrastructure, server, network, storage is completely the responsibility of the cloud service provider. But with virtualization software, what happens? Because the OS is installed by the consumer and as well as configured by the consumer, this affects the underlying system's security majorly. Okay, that's why what happens, the infrastructure security is shared between the cloud service provider and the cloud consumer in infrastructure as a service model. This part here, whatever the security is shared. Okay, now that we know how infrastructure as a service works, what are the responsibilities of whom? So physical security is completely of cloud service provider, but the virtualization was the infrastructure part. Infrastructure security depends on both consumer and the provider. Now we will talk about platform as a service model. In platform as a service, vendor takes care of the OS part as well. So the vendor, the cloud service provider, is responsible for patching, administrating and updating the OS as necessary and keeping security in mind, okay? And the consumer can install any software that is useful for them and run their application. The common use case for this is software development. It is very much used in software development as the consumer can test their software in an isolated environment without risking to damage the production, okay? And also they can test their software across a range of OS platforms. Since not worrying about the OS, they can only concentrate on developing the application. So the entire infrastructure part, right? It is the responsibility of the cloud service provider. Cloud service provider takes care of the infrastructure security completely in platform as a service. But when it comes to the platform, right, some of the configurations are still done by the consumer. So what happens? That becomes the shared responsibility of consumer and the provider. Now let's see what is software as a service model. Okay, in this, for example, Google Docs, Office O365 of Microsoft, your Gmail account, everything is a SaaS solution. In this, the entire platform and infrastructure part is the responsibility of the cloud service provider. Here, the cloud vendor is responsible for administrating, patching, and updating the software, that is the application part as well. What is the cloud consumer responsible for here is to upload and process the data, okay? But there are some configurations, applications or configurations that are maintained by the consumer. So this part becomes the shared responsibility of the cloud provider and the cloud consumer, okay? So what do we understand from here is that the physical part, server, network, storage, this is a physical part. This is always the responsibility of the cloud service provider. The data is ultimately the responsibility of the cloud consumer. So if we see the shared responsibility model, right? All the yellow part is the cloud consumer responsibility. Suppose say in infrastructure as a service. Okay. All this GRC, data, application security, platform security is all the responsibility of cloud consumer. The infrastructure part in infrastructure as a service, that is your clue, is the shared responsibility of both cloud consumer and the cloud provider. These ambiguous, that is the shared areas, right? That is where the risk is the highest because both the parties are responsible for it and both the parties should establish a strong separation of duties and responsibilities in order to protect themselves because both of them have different goals. Like cloud consumer, they want to maximize their computing capabilities and security while minimizing their costs. But the vendor, what do they want? They want to maximize their profits by minimizing what they provide. Okay, this is both in terms of utilities and security. So the shared area should always be mentioned in the SLAs, who should be responsible for what exactly, very specifically. Okay, and in platform as a service, till GRC, data security, application security, all this is cloud consumer responsibility. The platform security becomes the shared responsibility of both consumer and the provider. Okay. In software as a service, the application security becomes the shared responsibility. Okay. And underlying all this is cloud provider, solely the responsibility of cloud provider, that is platform security, infrastructure and physical security in SaaS. Let's go to the next question. We'll take the same scenario, migration to cloud. You need to explain what is cloud computing, what are the key characteristics of cloud computing, and also the pros and cons of each key character that you discuss. What is cloud computing? On the screen is from NIST 800-145. The NIST special publication 800-145 is for cloud concepts and definition. You can see a lot of words here, right? Like ubiquitous, convenient, shared pool, rapidly provisioned, minimal service provider interaction, on-demand network access. You don't have to worry about these now. We will talk about all of these terms when we discuss the key characteristics of cloud computing. For now, just understand that cloud computing is a delivery model which provides all these services that you can see in this picture, like for example, networking, server, storage, a number of applications to its customers. Now let's talk about the key characteristics of cloud computing. The first characteristic of cloud computing is on-demand self-service. Because of this characteristic, right, the customer can rapidly provision the resources without any or minimal interaction with the cloud service provider. So what happens in the traditional environment? If you want to get a server, right, you will have to request for it. The request will have to get picked up by, say, the infrastructure team. They will ask for your manager approval, then you have to get it approved. Once it is approved, you have to justify why you need this resource, and then the infrastructure team would take its own sweet time to get you a server. This might take like several days or even weeks, but this happens in cloud with a click of a button. This is an amazing feature, but it comes with its own disadvantages, like for example, lack of governance. This feature, on-demand self-service, provides the ability for the users to, spin up their own resources, like for example, VMs, virtual machines, by themselves without any process, provisioning or approval. This can lead to lack of governance and eventually lead to, violating the organizational policies. This can result in something called as shadow IT. Shadow IT occurs when cloud users access and use cloud systems and resources that have not been authorized by their organization. Okay, this can add up to a lot of cost to the organization. This is sometimes called as an expense of no use. The next key feature that we will talk about is broad network access. The slogan of this characteristic is access what you want when you need from any location, from any device over the internet. This offers the always on or always accessible feature. Broadband network access also comes with cons, that is disadvantages. Like for example, if the data can be accessed from any location and the data can be in any location, right, legal compliance becomes very complicated. Also, we need to consider bring your own devices. We'll have to consider how we manage these devices. Not all personal devices are set with the security level that matches with that of the organization, right? How to provide secure access from bring your own devices to the resources. So there are many complications here as well. The next key characteristic is resource pooling and multi-tenancy. Both of them work together. This talks about abstraction and apportion of resources across multiple consumers. This is one of the most important concepts of cloud computing. This forms the basis of cloud computing. In traditional environment, right, most of the resources are either underutilized or overutilized. For example, during their peak hours, a traditional server might be taking 90% of its resource utilization, and during the other times only 10% of its resource utilization. So either you're wasting it or overusing it. This is not a problem in cloud because cloud services are grouped together or pooled together and shared among multiple customers. Then when one customer server needs more resources, right, cloud service provider allocates more resources to that server. When the same server has less load, the very same resources are allocated to the other customer's server. This is done in a very systematic way and make sure there is no resource wastage. Now let's see about the cons associated with resource pooling and multi-tenancy. The auditing becomes difficult because of resource pooling and multi-tenancy. Also, because multiple customers are sharing the resources, there can be resource exhaustion for one customer because the other customer took up all the resources, right? There can be inference, there can be information leakage from one VM to another VM or from VM to hypervisor. Also, forensics becomes very difficult. Data destruction is very complicated because multiple customers are using the same resources and you don't have access to everything other than what is allocated to you. Also, because a large set of resources are pooled together, maybe these resources from different locations, right? Location control is very difficult and this might complicate the compliance. The next topic is rapid elasticity. Let's talk about scaling before we try to understand what is rapid elasticity. This picture here shows us how scaling works. Scaling is the process of adding or removing resources. This can also be called as provisioning or deprovisioning of resources. Suppose say you have a virtual machine. Cloud provides you a way to increase or decrease the size of the VM or amount of VMs based on the demand. When I say size, it means power of the VM. That can be CPU, memory, storage, network bandwidth, right? If the power of the VM increases like this, then it is called as scaling up. If it decreases, then it is called scaling down. And scaling up and scaling down is together called as vertical scaling. Here we are increasing the size of the VM. There is only one VM and we are increasing or decreasing the size of that VM. Then there is something called as horizontal scaling. Here the amount of VMs, the number of VMs, we are increasing or decreasing. Scaling in is where you decrease the number of VMs. Scaling out is where you increase the number of VMs. Now that you understand what is scaling, it is very easy to understand rapid elasticity because rapid elasticity is nothing but dynamic scaling. So you don't have to do it manually, but automatically the scaling happens as per the demand. So let's talk about the cons of rapid elasticity. One of the cons is abuse of cloud services. Like for example, there is a DOS attack on one of your VMs, right? That can result in provisioning a lot of resources, hence increasing the cost. The next key characteristic that we will talk about is measured service. This is also called as pay as you go. So here the customers are charged only for the resources that they use. It's just like, paying your electric or water bill. This is one of the most attractive features of cloud computing from a cost perspective. In cloud, right, you can actually granularly measure resource usage, control it, report it, or get alerted when you near or exceed the maximum usage limit. Next question. Your organization is moving to containerized applications. What security measures would you implement to secure containers in the cloud? So securing containerized applications in the cloud involves multiple layers of security measures so that you ensure that the containers are protected throughout their life cycle. Let's see some of the key security measures to consider. The first one is container image security. Use tools to scan container images for vulnerabilities before deploying them. This includes checking for known vulnerabilities, outdated libraries, and malware. And then use signed container images. This is to ensure the integrity and authenticity of the images being deployed. Also use minimal and secure base images. This is to reduce the attack surface. Also regularly update and patch base images. This is regarding the container image security. Next is container configuration security. Run containers with the least privileges necessary. Avoid running containers as the root user whenever possible. Next, set resource limits like CPU and memory on containers to prevent denial of service attacks caused by resource exhaustion. Next, configure containers to run with a read-only file system. That is, wherever possible, this is to prevent unauthorized changes to the file system. Next is network security. Use network policies to segment container networks and limit communication between containers to only what is necessary. Next, implement a service mesh to manage and secure communication between microservices, providing features like mutual TLS and traffic encryption. After network security is the runtime security. Continuously monitor containers at runtime for abnormal behavior, unauthorized access, or policy violations. And then define security contexts for containers to enforce security constraints like capabilities, seccomp profiles, app armor, or SE Linux policies. Next is orchestration security. Here, secure Kubernetes control plane and nodes, that is, ensuring proper RBAC, role-based access control, network policies, and secure API server communication. Also use Kubernetes namespaces to isolate different environments and teams. This is to minimize the impact of potential security incidents. Next is access control. Implement role-based access control, that is RBAC, to restrict access to container resources based on user roles and responsibilities. Also enable and regularly review audit logs to track access and modifications to container resources. Next, secrets management. Use secure tools like Kubernetes Secrets or HashiCorp Vault to manage and inject secrets into containers at runtime. Avoid storing sensitive data in environmental variables. So instead of storing them in the environmental variables, you can use secure methods to pass secrets to containers. Next is image registry security. So here use private container registry to store and distribute container images. This is to ensure that only authorized users can access them. And then enable continuous scanning of the container registry to identify and mitigate vulnerabilities in stored images. Next is compliance and policy enforcement. Implement automated compliance checks to ensure containers meet organizational and regulatory security standards. Also use policy enforcement tools like, for example, Open Policy Agent to define and enforce security policies across a container environment. Next is incident response. Develop and regularly test an incident response plan specifically for container environments to ensure quick and effective responses to security incidents. Also implement tools and processes for container forensics and auditing to investigate and respond to security breaches effectively. Next is backup and recovery. So regularly backup container images, configurations, and critical data to ensure that they can be restored in case of a security incident or data loss. Also develop a disaster recovery plan, that is DR plan, that includes containerized applications to ensure business continuity. So these are some of the steps or security measures that you can take to secure containers in the cloud. Let's go to the next question. How do you identify and manage shadow IT within your organization? Shadow IT, that is unauthorized cloud services. This question has two parts. First is identification and then the management. So this total approach is a combination of detection, policy enforcement, and education. First, let's talk about detection or identification. In this, implement tools to monitor network traffic. This is to identify unusual patterns or connections to unfamiliar cloud services. This can help you spot unauthorized services being used. Next, use a CASB solution to gain visibility into cloud services accessed by employees. CASB stands for Cloud Access Security Broker. CASBs can detect and report on unsanctioned cloud applications. and then deploy endpoint security tools that can track application usage on employees' devices. So these tools can provide insights into unauthorized software or services being used. Next, regularly analyze logs from firewalls, proxies, and other network devices to identify access to unapproved cloud services. Next, conduct surveys or gather feedback from employees about the tools and services they use. This can provide insights into potential shadow IT practices. This is about identification. Next is policy enforcement. Create clear policies regarding the use of cloud services. So, in these policies, you define which services are approved and also establish guidelines for requesting approval for new services. Next, educate employees about the risks and consequences of using unauthorized cloud services. Regular training sessions can help raise awareness and encourage compliance with company policies. Next, develop a streamlined process for evaluating and approving new cloud services. Make it easy for employees to request new tools so they are less likely to resort to shadow IT. Next, conduct regular audits of cloud service usage. So, this is to identify any new instances of shadow IT. This can help ensure ongoing compliance with policies. Next is enforce security controls such as blocking access to unapproved cloud services at the network level. This can be achieved through firewall rules, proxy settings, or CASB policies. And then integrate shadow IT detection and management with broader IT management and security tools. This creates a cohesive strategy for managing IT resources and security risks. Also, stay updated on new cloud services and emerging technologies, and then regularly review and update your approved services list to ensure it remains relevant and effective. So, these are some of the strategies that you can consider to effectively identify and manage shadow IT within your organization. Let's go to the next question. Describe your approach to detecting and mitigating insider threats in a cloud environment. First, conduct a thorough risk assessment to identify potential insider threats specific to your cloud environment. Understand the types of data and systems that could be targeted by insiders. Next, clearly define what constitutes an insider threat. This could include malicious actions, accidental breaches, and negligence by employees, contractors, or partners. Then enforce the principle of least privilege, enforcing that the users have only the access necessary to perform their duties. Next, use RBAC role based access control to manage permissions and limit access based on roles within the organization. Then, require multi factor authentication, that is MFA, for accessing critical systems and sensitive data. Next, implement continuous monitoring of user activities across cloud services. For this, you can use tools like CloudTrail in AWS, Cloud Audit Logs in GCP, or Azure Monitor. Also, collect and centralize logs from various sources, like, for example, access logs, application logs, network logs, system logs, and use a SIM, that is security information and event management system, to analyze them. Next, establish baselines for normal user behavior and use UBA, that is user behavior analytics tools, to detect anomalies that may indicate insider threats. Next, implement real-time anomaly detection systems to flag unusual activities such as large data transfers, unusual login times, or access to sensitive data. Next, Develop and enforce DLP policies, that is data loss prevention policies, to prevent unauthorized access and transfer of sensitive data. So you can use DLP tools to monitor and control data movements within and outside the cloud environment. Next, establish a dedicated incident response team trained to handle insider threat incidents. Develop and regularly update incident response procedures specifically for insider threats. You can also conduct regular drills to test the effectiveness of these procedures. Next, conduct regular review of user access and permissions to ensure they align with current roles and responsibilities. Next, perform regular compliance audits to ensure adherence to security policies and regulatory requirements. Next, provide regular training on security best practices, recognizing insider threats, and reporting suspicious activities to your employees. You can also conduct phishing simulations and other security awareness exercises to keep employees vigilant. Next, implement a whistleblower program that allows employees to report suspicious activities anonymously. Foster an environment where employees feel safe and encouraged to report potential insider threats. Next, use machine learning and AI powered tools to enhance the detection of insider threats by identifying patterns and predicting potential risks. Next, implement adaptive security mechanisms that can dynamically adjust security policies based on detected threats. Next, consider using blockchain technology to create immutable locks for critical transactions, ensuring transparency and integrity. Next, clearly understand the shared responsibility model and what security measures are managed by the cloud provider versus your organization. Leverage security tools and services provided by the cloud provider to enhance your security posture. So, these are some of the strategies that you can use to effectively detect and mitigate insider threats in a cloud environment. Let's go to the next question. How do you manage and secure multiple cloud environments to ensure consistent security policies and practices across all platforms? First, develop a comprehensive set of security policies that apply to all cloud environments. This includes policies for access control, data protection, incident response, compliance, and so on. And then document these policies in a centralized location, making them accessible to all relevant stakeholders. Next, identify and standardize security best practices that should be followed across all cloud environments. Establish security baselines for configurations, making sure that every cloud environment meets minimum security requirements. Next, use cloud management platforms, that is CMPs, that provide a single pane of glass for managing multiple cloud environments. For example, RightScale. And then automate the deployment and configuration of security controls across all cloud environments to ensure consistency. Next, use infrastructure as code tools, that is IAC tools, like for example Terraform, AWS Cloud Formation, and Azure Resource Manager. This is to define and deploy cloud infrastructure. This ensures that security configurations are applied consistently. Store these IAC templates in version control systems, like for example Git, to track changes and ensure compliance with security standards. Next, implement single sign-on, that is SSO solutions, to provide a unified access experience across multiple cloud environments. Use federated identity management to ensure that user identities are consistent and secure across all platforms. Implement role-based access control, define consistent roles and responsibilities across all environments. Apply the principle of least privilege, ensuring users have only the access they need. Next, integrate logs from all cloud environments into a centralized SIM solution, that is security information and event management solution, like for example Splunk or Azure Sentinel. Enable real-time monitoring and alerting to detect and respond to security incidents promptly. Ensure that logs from different cloud environments follow a consistent format for easier analysis. Implement policies for log retention and ensure compliance with regulatory requirements. Next, conduct regular security audits across all cloud environments to ensure compliance with security policies and regulatory requirements. Next, use automated tools to continuously check for compliance with security standards and policies. Next, map your security controls to industry standard compliance frameworks, like for example NIST, ISO 27001 or GDPR, to ensure comprehensive coverage. You can also generate unified compliance reports that cover all cloud environments. Next, ensure that data is encrypted both at rest and in transit across all cloud environments. Use centralized key management services to manage encryption keys securely. Next, deploy DLP, that is data loss prevention tools, to monitor and protect sensitive data across all cloud environments. You need to make sure that you apply consistent DLP policies to prevent unauthorized access and data exfiltration. Next, develop a unified incident response plan that covers all cloud environments. And also, you can conduct regular incident response drills to ensure readiness and coordination. Next, provide regular security training for employees. So make sure you cover best practices and specific challenges of managing multiple cloud environments. So these are some of the strategies that you can follow to effectively manage and secure multiple cloud environments, ensuring consistent security policies and practices across all platforms. Let's go to the next question. How do you implement network segmentation in the cloud to enhance security? So, implementing network segmentation involves dividing your cloud environment into isolated segments so that you can control and restrict traffic flow between different parts of your environment. This helps minimize the potential impact of security breaches and limit the spread of threats. So let's look at the strategy now. First, determine which parts of your network hold sensitive data and critical assets that require strict security controls. Next, clearly define the goals of segmentation, such as reducing attack surface, enforcing least privilege access, and improving compliance. Next, create security zones, that is, public zones, private zones, and restricted zones. Public zones are for resources that need to be accessible from the internet, like for example, web servers. And then private zones are for internal resources that do not require internet access, such as databases and application servers. Next is the restricted zone. This is for highly sensitive resources, such as financial systems or sensitive data storage. This requires the highest level of security. Next, create separate VPCs, that is virtual private clouds, for different parts of your environment, such as development, testing, and production. Within each VPC, create subnets for different tiers of your applications, such as web, application, and database tiers. Next, use ACLs, that is access control lists, to control inbound and outbound traffic at the subnet level. This is by specifying which IP addresses and ports are allowed. Next, use security groups to define rules that control traffic to and from individual instances or services. Ensure that security group rules follow the principle of least privilege. Next, use cloud native tools and features. First, let's look at AWS. There is AWS VPC. You can use AWS VPC to create isolated network segments. Then there is AWS Transit Gateway. You can use this to centralize connectivity between multiple VPCs and on-premises networks. Next, AWS Private Link. Use this to establish private connectivity to AWS services without traversing the internet. Next, Azure. There is Azure VNet, that is Azure Virtual Network. This you can use to create isolated networks in Azure. Next, we have Azure NSGs, that is Azure Network Security Groups. This you can use to apply network traffic filtering rules. Next, there is Azure VNet peering. So you can connect VNets within the same region or across regions. Next is Google Cloud. There is Google Cloud VPC to create global and scalable networks. Then there is Google Cloud Firewall rules to create granular control over traffic. Next, there is Google Cloud Interconnect. This is to establish private connections between Google Cloud and on-premises networks. Next, protect web applications using web application firewall from common threats like SQL injection and cross-site scripting. Next, you can also use next generation firewalls to provide advanced threat protection and deeper inspection capabilities. Then deploy IDS or IPS solutions, that is intrusion detection and prevention systems, to monitor and analyze network traffic for suspicious activities. Next, you can use tools like AWS CloudWatch, Azure Monitor, or Google Cloud Operations to monitor network traffic and detect anomalies. Next, enable logging for all network activities and set up alerts for suspicious or unauthorized access attempts. Next, conduct regular audits of network configurations and access controls to ensure they adhere to security policies and best practices. Next, use site-to-site VPNs to establish secure tunnels between your cloud environment and on-premises network. Then you can also use client VPNs to provide secure remote access to your cloud resources. Next, ensure all traffic between segments and to and from the cloud is encrypted using TLS SSL. Next, use software-defined solutions, that is SDN solutions, to create fine-grained security policies at the individual workload or application level. Next, adopt a zero trust approach to verify and validate all access attempts within and across network segments. Next, use automation tools to ensure systems and applications within each segment are regularly updated and patched. Next, conduct regular vulnerability scans to identify and remediate security weaknesses in your network segments. So by following these steps, you can effectively implement network segmentation in the cloud. This increases security by isolating critical assets, restricting unauthorized access, and minimizing the potential impact of security incidents. Next question, what security measures would you implement in your CI/CD pipeline? So implementing robust security measures in a CI/CD pipeline is important to ensure integrity, confidentiality, and availability of your software delivery process. Let's look at some essential security measures. First is source code security. For this, use version control systems, like for example, Git with access controls and permissions. Next, implement code review processes to catch vulnerabilities early. Next is build server security. So you secure the build environment with restricted access and strong authentication. Use containerization, like for example, Docker with minimal privileges for build processes. Next, dependency management. Regularly update and patch dependencies to mitigate known vulnerabilities. Use dependency scanners to identify and remediate vulnerabilities in third-party libraries. Next, integrate security testing into your CI/CD pipeline, like for example, static code analysis, dynamic application security testing. You can also include automated security checks for common vulnerabilities. For example, OWASP top 10. Next is artifact management. Securely store build artifacts and ensure they are tamper proof. Use signed artifacts and checksums for integrity verification. Next, implement least privilege access controls for CI/CD tools and environments. You can also use multi-factor authentication MFA for accessing critical systems. Next is secrets management. Make sure that you avoid hard coding secrets, example API keys or passwords, into source code or configuration files. Use secure vaults, like for example, AWS Secrets Manager for storing and accessing secrets. Next, monitor CI/CD pipeline activities for suspicious behavior or anomalies. And then implement logging and alerting mechanisms for security events. Next, ensure compliance with security standards that is relevant to your application, like for example, PCI DSS, HIPAA, or GDPR. And then conduct regular security audits and reviews of your CI/CD pipeline. Next, provide security training for developers and operation teams. Foster a security-aware culture to prioritize security throughout the development lifecycle. So these are some of the security measures that you can incorporate into your CI/CD pipeline to significantly reduce the risk of security breaches. So that's it for today, guys. I hope this video helped you understand a little bit more about cloud security. There'll be other videos on the same topic, that is cloud security interview question and answers. I will link them in the description box. Don't forget to like, subscribe, and share our videos. That helps us a lot. See you soon again. Bye-bye.